naming yourself with that proper protocol, will not be admitted into the class. Okay, so just make sure that you have named yourself properly with that ID number and your own name, and then only you will be admitted inside the class. So this.
Good afternoon, ma'am.
Yes, good afternoon. So give me a minute or two. I'll just finish admitting all these students who are coming in now. And then we'll get started. Okay, so let's get started now. The CRs are there of both the divisions, division 2 and CRs.
Yes, ma'am. Yes, ma'am.
You all are there. Okay. So what you have to do at the end of the session, you have to give me the attendance. Now I guess that some of you are also traveling. Is that right? Am I right? Are some students traveling?
No, ma'am. Division 2 and Division 3 is already there in hostel.
Oh, yes, yes. You all are already there. So there is no question of it. So we should expect 100% attendance, right? Unless it is a medical issue. Okay, so give me a minute. Let everybody just come in so that nobody misses the content. We have got 53 students. CRs can just tell your batchmates to join quickly.
Yes, ma'am.
Yeah. Okay, so last class, we had started with differential equations. Is that correct? Can you see my screen? Yeah, you can see my screen, no? Yeah. So we had started with differential equations. Then we had seen the definition, general definition of differential equation. And after that, we had seen the definition of the ordinary differential equation. Then we had seen the definition of the partial differential equation. Then we saw what is order and degree.
Ma'am, excuse me, ma'am. Ma'am, you can check waiting room.
Yeah, just give me a minute. Huh?
Okay, ma'am.
Okay, yeah. Yes, okay. All right, fine. So I think now there's nobody in the waiting room. All right. So now from today's class onwards, also I told you the definitions of the solution. If you recall, I told you the definition of the solution. Is that correct? Yes or no? And then we had also seen formation of the differential equation. So now what we are going to do, we are going to start with the actual solving of the differential equation by various methods. So are you with me? Have you made some rough notebook at least at this stage?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
Once you get your that stationery and all that, then you can make the notebooks. I think for mathematics, you will be given 2. Okay, 200-page notebooks. That is a requisition which we have given from our side. So once that stationery is distributed, then again you can make the proper notebooks. In the meantime, please ensure that you're writing everything in one place. Okay. Yeah. So the first method which we are going to see over here to solve the differential equation is the variable separable method. Now, obviously, when we are saying variable separable, we are going to separate the variables in the equation and then we are going to solve. So in other words, we should be able to write our equation in this format. Okay, is equal to, if we integrate this, then we are going to get the solution. Idea is clear to everybody. So on one side, you must have X, on one side, you must have Y. Then only you will be able to integrate with respect to X and Y. Is this concept clear to all of you in the class? Is it clear or not clear? Yeah, division 2 and 3 students. I hope I'm audible to you.
Clear, ma'am.
Clear, ma'am.
Okay, so just see this.
And please repeat once again.
We have to separate the variables and then we have to solve. You have to mute yourself. Somebody is unmuting.
Dhruv Kakade, you are.
Dhruv Kakade.
So see, otherwise the voice will echo, no? Then you can't understand. So what I was telling you, here we have to separate into the variables, whichever variables you have. So for example, if you have X and Y, you must bring X on one side, you must bring Y on one side, and then only you will be able to perform the integration. Idea is clear to you?
Excuse me, ma'am. Ma'am, can you repeat this once again?
Arey Bapre, now this is the third repetition. Who is this? Are you all paying attention properly in the class or not?
Yes, ma'am.
Okay, so now I will not repeat it. Now you ensure that everybody is paying attention properly. Okay, purposely I'm not going to repeat. Otherwise, I'll get 10 more requests like this. So everybody has to be, once I start the lecture, that means the teaching part, you all have to be at full attention. Okay, this much you just remember. All right, now just see this equation. dy by dx is equal to e raised to 3x minus e raised to 2y plus x square into e raised to minus 2y. Now we are going to use variable separable method to solve this particular sum. So how will we separate it? What I can do? Can you suggest?
मैम e3x minus 2y को e3x upon में e power 2y लिख देंगे.
No, you just do one simple thing. Just take e raised to minus 2y common. And here you will have e raised to 3x plus x square. Idea is clear to you?
Yes, ma'am.
Yes or no? Acha, Dhruv Tyagi. Where is Dhruv Tyagi? Please unmute yourself.
Yes, ma'am.
Just 1 minute. So Dhruv Tyagi, I'll put you in the waiting room because you have not named yourself properly. Please put your IMU ID number and rejoin. Dhruv Tyagi, are you there? Yes, Dhruv Tyagi, are you there in the class?
Yes, ma'am. Yes, ma'am.
So please leave the meeting and you rejoin by naming yourself properly. Can you do that?
Okay, ma'am. Yes, ma'am.
Yeah. Put your IMU ID number, okay, and then come back. Yeah. So here we have to separate. So here what I've done, see, I took e raised to minus 2y outside the bracket, and here I've got e raised to 3x plus x square. So I've got terms in y and terms in x. Now they are separated. Now what I'm going to do, I'm going to take this e raised to minus 2y this side. So it will become e raised to 2y is equal to, and then e raised to 3x plus x square dx. So this is in the variable separable form. So once it is in the variable separable form, what we can do, we can just integrate and find out the solution. Now all of you, you all are very smart students. So you can tell me integration of e raised to 2y, how much it is? Integration e raised to 2y upon 2 is equal to, yes, now next one, 3x upon 3 plus
X cubed by 3.
Yeah, and since this is an indefinite integral, so therefore always constant of integration has to be added. So now we can leave the answer here at this stage. Okay. If you want, you can further simplify and you can try to bring the equation in this form, y is equal to fx, because that will be the equation which relates to the differential equation. But this is not a compulsory thing, just to note it. See, putting the equation in this form in y is equal to fx, it is useful only if the equation is not more complicated than what it earlier was. Okay, so right now as we are seeing, that here we have got e raised to 2y, here we have got e raised to 3x, x cubed by 3 plus c. So it is an okay form. So I can leave it. If you want, you can do one more step. Take this 2 here to this side and multiply it and then write e raised to 2y. One last step, if you want, you can take log of both the sides and then put it in the form of y is equal to some log of something. This also you can do. But otherwise, as such, we have already obtained the solution to the differential equation. Is this point clear to everybody? Yes or no?
Ma'am, can you repeat this again?
So this repetition business is being too much, so I will not repeat like this way. Whenever I am speaking, you will listen to me only one time. Otherwise, I will take 1 year to finish your syllabus, isn't it? Students, you agree or not? So we can't keep on repeating. You ought to be paying attention. Were you away from your screen? Were you away from your screen? Repetition party. So don't be away from the screen. Just as you are attending normal offline class, like that only you try to attend the normal online class. Is that clear or what to you? Yes or no? Got it?
Yes.
Please confirm it. Yeah, okay. So that is going to be my method. I expect that you will be always there and attending the class properly without being away from the screen, so that unnecessarily we don't have to go on repeating all the things, okay, which is not required also. All right, now what I'll do, I'll just put up a new sum on the board, where again once you can try to solve the sum by separating into two different variables. Okay, so you can just try this. Let us see if you are able to separate. I'll just give you a very easy sum. Everyone has to pay attention, just like you do in the offline class. In the same way, you keep paying attention, so that then there will be no need of us having to repeat all the things. Okay, so can you separate it? It's very easy. Purposely I put a very easy question over here. Yes, anybody? It's a very
You
easy
will take it to
question.
RHS, ma'am, and then do it.
What you will take to RHS?
X root 1 minus y square dx.
Okay, yes, all right. You can do like this. dy is equal to minus x root of 1 minus y square dx. Okay, you can write like this. Now, after that?
Then we'll take root 1 minus y square that side and root 1 minus x square RHS side.
Yes. So we can transfer this y term this way, and we can transfer the x term to the other side. And now is it separated? Yes. So can we integrate this? Okay, now this is a very simple integration. Can you tell me the integration of this part?
1 minus y square equal to t.
You can put 1 minus y square is equal to t. Now all of you already know, derivative of this thing. What is the derivative of, 1 second, give me a minute. What is the derivative of root x? Yeah, anybody?
1 by 2. 1 by 2 root x. 1 by 2 root x.
Yes. So using that same theory, can you just tell me what will be the derivative? What will be the integral of this particular term? So you can use the same theory. Yes, please. Or you will have to do the lengthy way to 1 minus y square is equal to t and all that. But if you know your basic integration well, then you will be immediately able to tell me the integration of this. So can you
2
think
root 1
about?
minus y square.
No, not 2 root, only root of 1 minus y square. Just think about it. See, just to think about this, what I can do, I will do one small manipulation. I'll just, multiply this denominator and numerator by -2. Are you getting it or what I'm doing? Getting it? Yes or no?
Yes, ma'am. Yes, ma'am.
If I do like this, okay, and then I put this, so multiplying and dividing just by 2, this small manipulation I've done, because I know derivative of root x, it is 1 by 2 root x. So I'm going to use this particular basic thing for quickly giving me the answer to this integral. So now that I've got this over here in this way, what will be the integral value? Just tell me now. It's very easy. Yeah, derivative of 1 minus y square is minus 2y, which we have already got here in the numerator, isn't it? So how much will this be? Quickly, students, I've put everything in place. Just have to work it out and tell me.
Root y.
Root y nahi. We have root of 1 minus y square, no? So derivative of root of this 1 minus y square term, it is minus 2y, which is now there in the numerator. Isn't it? I manipulated it. Not y square.
Minus 1 by 4 root 1 minus y squared. is it?
No, not minus 1 by 4. Why 1 by 4? It is minus 1 by 2. Minus 1 by 2. This much, no? Or no?
There's one more 2 in denominator, right?
There is a 2 in the denominator. Why I brought that 2 in the denominator? Because I want to use this. Correct? So will this be there or not be there? This extra term. It won't be there. Correct? Only thing is that this is going to be minus sign. Right? See, this whole thing will be one group. This will be one group. This is going to be your this term, which I have written over here. Got it or what, students? Getting it, no? See, whenever we are writing the derivative, remember this one, how it has come. This is d by dx of x. Right? No? So you have to, over here, this is the derivative of this term. So here also, this is the derivative of this term. Now its integral means antiderivative, I told you. So it is going to be minus root of 1 minus y square. Correct? Getting it or what, students?
Yes, ma'am.
Yeah. Now what will be this side? Right hand side? Same way.
Minus times and root 1 minus x square.
No, in this case, is it going to be minus or what? How minus?
I guess this is positive.
It is going to be positive. So how much will this be?
Root over 1
minus x.
Yes, that's right. Plus c I can write. So what I'll prefer to do is, I'll just club together these terms. Okay, plus root of 1 minus y square is equal to c. And that's it. That's my answer. So I have taken everything to c. If I take c to this side, it's a constant only. So no need to write minus c or anything. C you just keep as c. This thing you just remember. Whenever you are solving differential equations, just treat c as a constant. So don't try to put minus c, c by 2, c raised to something. No need of doing all these things. Idea is clear to everybody? Variable, separable. Those of you who are noting down the things, note down. If you are not able to do, see, if your basics are good, then this thing you will get it immediately. Now, if you think that you are not comfortable that way, then you'll have to do the lengthy way. Then you'll have to put 1 minus y square is equal to t and all that, and then start solving. That also you can do if you wish to. If you are not comfortable, but that's why what I said, that just get, familiar with once again the basic formulas.
Ma'am, can you please explain that part we have circled?
Which part?
Ma'am, that part which you have circled it.
No, now I have circled in so many places. No, which part you want me to sort of.
Minus 2y, ma'am.
Minus 2y, no? This is
Yes,
one
ma'am.
group. This is one group, no? Yes or no? Basic.
Yes,
See,
ma'am.
see, whoever is asked this question, just tell me what is the derivative of root x?
1 upon 2 root x.
Okay, tell what is the derivative of x square?
2x, ma'am.
Students, I'm noticing that you all are coming very late to the class. Like it is 2:21 and still students are entering the classroom. So you should not do like this. Yes. Who? Yes. Tell the answer.
Excuse me, ma'am.
Yes.
Ma'am, actually, we came late from workshop, like around 1:52, and then some students went to mess because they wanted to have their lunch. That is why they are joining late.
But so they didn't know that the theory classes are there.
Ma'am, actually, it takes time for us to come from the admin block to the hostel block. That is
No, 1 sec. But how come you were left at 1:52 when the theory class starts at 2 o'clock?
Ma'am, after practical, actually, sir takes a viva for around 5 to 10 minutes. Then we come from.
Okay, then can you do one thing? See, we have to go as per the timetable. So we will be now, see, just now I'm just delaying and all because this is a starting, but afterwards I'll be starting like at the right time. That means when the class is at 2, I'll be just starting off at 2. Whoever is there will attend. But in this way, you all will lose course content. So can you bring this to the notice of the year coordinator, please?
Okay, ma'am.
Yeah, so just tell him, whatever it is. So if he wants to, like, maybe then if that is the way, then maybe we should start your class at 3 and then we can go on, but then you will end at 7:45 because 1 more hour will get added that side, right? So we may not really want to do that, but you bring all this to the notice of the year coordinator, okay?
Okay,
Yeah, because you will face a problem in every class, right? Whenever your class is at 2, right? Are you the CR?
No, ma'am, I'm the DCR.
Okay, so you got my point, right?
Yes, ma'am.
So you will face this problem throughout the semester and for every class which is at 2, whether it is mine or some other faculties. Got it? So just bring this to the notice of the year coordinator that this is your problem and that you are not able to make it to class on time because then you are obviously you want to have your lunch and all that also thereafter. Correct? Yeah. So now let's continue with our this thing. Yeah. Root of x square. What's the derivative? Root of x square. Whoever was asking me the doubt. The same student should answer derivative of root of x square. Yes, please. Yeah, derivative of root of x square. Anybody?
Ma'am, 2x into 1/2 root x.
2x upon 2 root?
2 root x.
No, 2 root x out. 2 root
2
x
root x
square.
square.
Okay. Now you tell me the derivative of root of 1 minus x square.
Ma'am, minus 2x upon में 2
minus 2x upon 2
bracket में 1 minus x square. Under root में 1 minus x square.
Root of 1 minus x square. Okay. All right. So this is what I've used over here. Got it or what? Got it? If this is the derivative, then if you integrate, you will get this thing. Got it or what? Are you getting it? What I'm saying?
Yes, ma'am.
Yes, ma'am.
Derivative, this integral is antiderivative. Okay. Basics need to be strong in maths, the foundation has to be very good. Then you can build a very good building. Okay. It's a kind of a structural subject. So once your foundation is good, then there is no, end to what you can achieve. All right. Anyways, so this is our solution. Now, if you are not so comfortable with your basics, then you'll have to go the lengthy way. Put 1 minus y square is equal to t and all and start. All right. So this is variable separable. Yes. So let's continue now. see, sometimes directly we may not be able to separate into different variables. So at that time, we need to reduce the given equation to the variable separable form. So that's why now we are seeing reducible to variable separable. So what you can do is you can write down over there reducible to variable separable. Okay, now for reducing to variable separable, how do we go about it? We make a suitable substitution. Why I'm saying a suitable substitution? It depends on the problem, like what you're going to substitute and where. First of all, what you do, just check it. Can you separate into variables in the given form? No. The answer is obviously no. So when this happens, you make a substitution. Usually that substitution is like this. Y is equal to Vx. Alternatively, it can also be X is equal to Vy. And sometimes there are some problems where you will have to innovate and make a substitution. So that kind of an example also I will show you. So if you say Y is equal to Vx, then dy by dx will be equal to V plus X times dV by dx. Is this clear to you, what I've done over here? Yeah, students.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So now what you will do, you are going to make that substitution in this problem. So I'll just write down everything. See, first, you can also have one more step where you do this division. Okay. And then we will make the substitution. So that way it will be a little easier for you. You can have even one more step where you can write like this. So this is just to increase your comfort level. So what you can do is, this will be is equal to 2. Now in place of y, we are going to put Vx. So Vx square, and into bracket, I'll just substitute everything for dy by dx. Is it clear what has been done? Are these steps clear to you or not?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. So now what you can do, so you will have to, you have to think for yourself a little bit. Now here what I can do, I can take x square like this, common. So this side I will have 2v x square into bracket v plus x into dv by dx. And now what we can do, we can cancel out this common x square. Getting it, what we are trying to do over here? Is the sort of, am I getting across to you? Yes or no?
Yes, ma'am. Yes, ma'am.
All right. So now what we will do, I'll just, you'll be comfortable if I just erase some portion of the screen.
Yes, ma'am.
Yes, ma'am.
Yeah, the reason why I'm doing that is that, so that everything is visible in the same screen itself. Okay, so, all right. So we'll continue from this step. Now 1 plus v square is equal to, we can multiply this inside the bracket if we want, or you can just, divide it this side, but I'll prefer at this step, I'll just multiply inside the bracket. Okay. And then we'll simplify further. Right. And now I can transfer this 2v square to the left hand side. So what will happen? I'll get 1 minus v square is equal to 2vx dv by dx. Are you getting it? What all I'm doing?
Yes, ma'am.
Yes. Okay, very good. So now at this step, I think you can appreciate it that we are going to be able to separate into variables. So see what I did. Now here I'm writing like this, x dv by dx. Followed?
Yes, ma'am.
Now we very comfortably we can separate into variable separable parts. So what I'll do, I'll just take
2v upon 1 minus v square dv.
Yeah, correct. 2v upon 1 minus v
X into
square
dx.
dv
Dx by x.
equal to dx by x.
X.
That's right. Now it's got separated. Now we can easily integrate this. So it's a very easy integration. So 2v. So once again the same thing. So minus 2v, isn't it? Because derivative of 1 minus v square is minus 2v. So what will be the integration?
Log 1 minus v square.
Yeah, but in that C, a derivative of 1 minus v square is minus 2v, isn't it? So,
तो मैं minus लगा दूंगा.
Yeah. Shall I erase the last two lines on the screen?
Yes.
Those of you who are noting down, especially I'm asking you all. Okay, so now just see over here. See, this is 2v upon 1 minus v square, isn't it? Ideally, we would want minus 2v upon 1 minus v square, but here we have plus. So that additional minus sign, you will have to add it. So what will be the integral value?
Minus log 1 minus.
Minus log 1 minus v square.
Minus log 1 minus v square is equal to, this is
Log
very
x.
easy,
Log x.
log x.
Plus c.
Now see, now here one important point I have to just tell you. See, whenever you have got all the terms as logs, no, you try to put the constant term also as log c. I'll tell you why this is going to be helpful to you. Now what I'll do, I'll just take x and v on one side. So I'm going to write this way, log x plus log 1 minus v square is equal to log c. Okay, whatever. Now log a plus log b. So using the rules of logarithms, this is going to be log of x into 1 minus v square is equal to log c. Now both the sides we have got log, so we can just cut the log on both the sides and this will be equal to c. Now what is the value of v? See, we had made the substitution y is equal to vx. So what will be the value of v? Yes, what will be the value of v? Y divided by x.
by x.
So I'm just going to do that resubstitution. So y square by x square is equal to c, and that's it. So that's the solution. Now I told you, if you want, you can simplify it. You can cross multiply by x square and all, but it's really not going to serve the purpose. So we are going to just stop here, and that's it for us. If you
marks तो पूरे ना भी छोड़ेंगे तो.
yes, you will get the full marks. Don't worry. Okay, so it's not. See, simplification. This is my take on this issue. Simplification is done by people in different ways, isn't it? So there are people will think in a different way. So finally, just ensure two things in your, rather only one thing you ensure in your differential equation solution, that you are integrating properly. Because I told you, see, solution means what? It is the integral, isn't it? Or the primitive. So basically, if you integrate properly, your answer will be correct. Only in that part, you should not make a mistake. Idea is clear to everybody. Got it or what?
Yes, ma'am.
See, because this, you can go on simplifying in various ways. Different people will have different ways of simplifying. So that is not the issue. You just ensure your integration is correct and you're coming down to this last part. That's it. Okay, so
you forgot the minus sign.
Where the minus sign I've forgotten?
Minus log 1 minus v square.
Where minus log 1 minus v square?
Then ma'am, you solve that log x plus log 1 minus v square.
So I took this side, no? Log x plus.
Then log c.
That's what I told you. If it is minus log c also, it is a constant only at the end of the day. Got it or what?
Yes, ma'am. Yes, ma'am. Sorry.
Minus c. No problem. You can clear your doubts in this way. C minus log c. We can write this way, c raised to minus 1 means what? It is constant only at the end of the day. Got it or what?
Yes,
I'm getting my point.
Yes,
so whatever, whether you write this way, that way, whichever way you write, but ultimately it is just c. That's okay. Idea is clear to all of you? Yeah. Okay. Now in your syllabus, we are just doing these kind of problems, but suppose we were doing little more advanced types of differential equations where it was boundary value problem and all, then there those things may have mattered. But here now, this is just simple for us, constant of integration. So we can just leave it as it is. Idea is clear to you? Yes or no? Up to is this point, anybody wants to ask me any question, any doubt? By all means, you can ask. Acha. Okay. All right. So we will go to the next part. Now you can write down the heading, Leibniz linear equation. Leibniz linear equation. Just write down the heading. Once you write down, just confirm it to me that you have written, then I'll start the explanation.
Done.
Done. Okay. Yeah. So what is it? So this is the equation which is in this form. See, dy by dx plus py is equal to q. Now one very important thing, just keep it in mind. P and q, they can be constants or they can be functions of x. This you remember it. Okay, this is going to matter a lot. Remember that P and Q, either they can be constants or they can be functions of x. So if we have this kind of equation, it is called the Leibniz linear differential equation of first order. All right. So how to solve these types of equations? So for that, we have the concept called as integrating factor. IF means integrating factor. How do we find this integrating factor? Simple. Integration of e raised to p dx. That is our formula. Once you find this integrating factor, how will you find the solution to the problem? By using this formula. Y multiplied by integrating factor is equal to integration of q into integrating factor dx plus c. Is the definition of Leibniz linear equation clear to everybody? Definition. Just tell me. Only remember the important point. P and Q, either they will be constants or they will be the functions of x. Just remember that. Okay, now while we are on this, I have to tell you that this same thing we can write in another way also. See how I'm writing. Dx by dy plus px is equal to q. Now you just tell me some things. In this case, what will be P and Q? If I write the equation in this way, if this is the equation, what will be P and Q? Functions of, either they will be constants or they will be functions of complete sentence. They will be functions of y. So you can have it both ways. In this case, what will be the integrating factor? E raised to integration P dy.
dy.
And what will be the solution formula? X into integration factor, right, is equal to integration q into integration factor. In this case, you'll have dy plus c. Can you see the changes? Changes are clear. Are the changes clear to you? In case you have
Yes,
to write, in case you have to write the equation this way, or let us say the sum is given to you in this way. So I have told you both the ways. So you can please note this other one also. Note this. Note the formula for the integrating factor. Note the formula for the solution, and also note the alternative. This is also important. So either way, you can just answer the questions. Was one of you trying to call me during the class? Is anybody having this mobile number 940498733? Is that somebody amongst you? Huh? Students? Is it one of you who was trying to call? No, I guess. Okay. All right. No problem. Have you noted down students of division 2 and 3?
Yes, ma'am. Noted.
Yes, ma'am.
Yeah, okay. Acha, CRs are there? CRs, are you there?
Yes, ma'am. Yes, ma'am.
So the CRs, you all just on behalf of your divisions, you just contact the your coordinator about the workshop thing. Okay.
Yes, ma'am.
See, because you are in the first year, sometimes you may not have the courage to directly speak to that particular faculty only and tell. So better you tell the YC and he will do the needful. Okay. Got
Yes,
it out.
And can we shift because all our classes finishes at 6:45, and we have our dinner from like 7:15, the least 7:15. So can we shift it to 15 minutes later, like all the classes, like from the next week? I'll talk to sir that to shift every class like for 15 minutes late. So the last class will end at 7. So it will be fine. We will get more 15 minutes for lunch, even if we reach 2 o'clock.
No, but the idea is your workshop is supposed to be over at 1, no, or 12:30. What is the timing of that?
Ma'am, 1:30, ma'am.
No, ma'am, this time is good.
No. See, regarding this timing and all, no, regarding the timing and all, no, actually it is a higher level decision. See, timing of the institute, we can't decide at our level. You're getting it or what?
No, ma'am, we don't have time for lunch also, ma'am.
That only what I'm saying is that this timing business, no, that is what you can do is you can bring it to the notice of your coordinator. You're getting it what I'm saying?
Yes, ma'am. Yes, ma'am.
He's teaching you, no, Mendare sir, he's taking the class for you, no, isn't it? So during the class or apart from the class time also, sometime the CR, all of you don't start shouting in his class. The CR can contact the YC separately and bring the issue to his notice. Got it or what?
Yes, ma'am. Yes, ma'am.
Yeah, because see, otherwise what will happen? Initially, the faculty may be a little bit liberal and they may consider your request, to start 10 minutes late, 15 minutes. But afterwards, everybody will be wanting to complete their syllabus also, no? So then they may not agree. You're getting my point, no? What I'm trying to tell you.
Yes, ma'am.
Then you will unnecessarily lose the content of the class. So what you do, you bring this notice quick issue, whatever it is, to the notice of your coordinator, so that he will find the solution and solve the problem. Idea is clear to you?
Yes, ma'am.
Yeah, but just don't keep it pending. Otherwise, then it will be this way only every time. Okay. Now this theory part is clear. Now let us solve the sum. See, now this is the equation. Okay, what we are going to do, first we are going to put it in the standard form. What is the standard form? dy by dx plus py is equal to q. So to make it in the standard form, what we will do? We will divide throughout by this x plus 1. Now what I told you, p and q, what they are? Who will tell me? P and q are, complete my statement. P and q are
2 upon x plus 1 b and 1 upon 1 x.
No. Generally tell me. Generally P and Q are what? Generally P and Q are either what?
Constant or
Or
function of x.
Function of x.
function of x only. Okay,
Yeah,
remember
only.
that. So 2 upon x plus 1, what it is? P. And 1 upon 1 plus x, what it is? Q. Okay, now we are going to use this formula. First, we are going to find out the integration factor. Okay, so for integration factor, we are going to use this formula e raised to integration p dx. Now this is a very easy integral, 2 upon x plus 1. Yes, so the smart students in the class should answer quickly. What is the integral? 2 upon x plus 1, fast.
2 log x.
X plus
2
1
log x plus 1.
And if it is 2 log x plus 1, then this will be equal to
e
plus
log
1
x
whole
plus
square.
1 की power whole square.
e raised to log means what it is equal to?
x plus 1 whole square total.
X plus 1 whole square.
Yes, so the integrating factor is this one, x plus 1 whole square. Okay, now we have got the integrating factor. Now we are going to use this formula for finding out the solution. Okay, so we will start writing up. Just 1 minute. Y into integrating factor. So x plus 1 square is equal to integration. I hope that you wrote the formula and all. So q is 1 upon 1 plus x. So over here again x plus 1 whole square, integrating factor dx plus c. And this is a very, very simple integration. You can just tell me what I should write is equal to. Now, you know, this will get cancelled out. So we'll be left only with x plus 1.
X
So,
square by 2 plus x.
yes, plus c, correct. And that's
Yes.
your answer. Now see, whether you want to shift this x plus 1 square to the right hand side and all, that is separate. Here you can stop and this will be the answer which you can report. Idea is clear to everybody? Yes or no?
Yes, ma'am.
Getting it, no, it is easy. Only thing is see, throughout this, remember that thing, what I told you, solution means integral. Okay, solution means integral. So if your integration part is okay, then you can never make a mistake in the solution. So that you just take care of. Getting it out, what I'm telling you. Idea is clear to you, students?
Yes, ma'am. Yes.
Yes, ma'am.
Okay, what I'll do now, I'll give you one summer. You tell me what all has to be done. Just here, same we are doing, same type. Cos square x dy by dx plus y is equal to tan x. Okay, what I should do? I have to put this in this form. dy by dx plus py is equal to q. Now what should I do? Just tell me.
Divide by cos square x.
Divide by cos square x. So I will be able to write this way. Okay. Now at this point, you know, we can make one more small simplification. 1 upon cos square is how much? How much? Secant square is equal to secant square x tan x. Okay. Now which is p and which is q? This will be? Yeah, and this is going to be q. Right, now we have to find the integrating factor. So once again, very easy. Integrating factor is e raised to integration p dx. So what is the integration of secant square x? Yeah, quickly. Tan x. Yes, that's right. Now we are going to do the solution part. So y into integrating factor e raised to tan x is equal to integration. Okay. Now q into integrating factor. So q is secant square x into tan x into e raised to tan x dx plus c. Now left hand side, nothing has to be done. Only the right hand side we have to take care of. So can you suggest to me?
Ma'am, tan x को t ले लेंगे.
Yeah, that is right. Put tan x equals to t. So secant square x dx will be equal to dt. So therefore, what will be your sum? Just see, t into e raised to t dt plus c. Now t into e raised to t dt, you know, it's a very common integral. Can anybody quickly tell me the integration? Many times we use this. How much it is? But so many times you might have used this, isn't it? How much it is? E raised to t into
E to the power t minus 1.
to t minus 1 plus c. And now last step, you can again resubstitute the value of t. So tan x minus 1 plus c. And LHS will remain as it is, y into e raised to tan x. Idea is clear or what? How we are going about it? Are you getting it?
Yes, ma'am.
Following, no? Yeah. So see, many times, so basically you should know how to integrate. That's it. If you know your integration well, then there is no issue at all. Then it's a cakewalk, this solving the differential equation. So we have seen this, which one is it? Leibniz linear form. Now I will just introduce the Bernoulli's form. We won't solve the sum, but I'll just introduce Bernoulli's form, and next time we will solve the sum. Okay, now
Excuse me, ma'am, can you
yeah.
show us the previous one solution?
Yeah, I can show you. One second. Wait a minute. This, no? This
Yes,
one.
ma'am.
This
Yes,
one
ma'am.
only, no? Oh, okay. So what is the class strength? 2 and 3, division 2 and 3. Division 2, strength of the class.
Division 3, 35.
Division 2, how many? 35 only, no?
34.
34. Okay. 34 and 35. So we are, at some point we were 70, somebody dropped out. So today I think everybody is present, right?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay.
Thank you, ma'am, for the.
Yeah. Yeah.
All are present.
All are present, right?
Yes, ma'am.
Yeah. Okay. See, this is the Bernoulli's form. See, this is Bernoulli's form. Now, we have just seen Leibniz form. Can you tell me the difference between the two? Observe and tell me. Just see what is different. Leibniz form was like this. dy by dx plus py equals to q. So what has changed? This is Leibniz form. What has changed?
RHS.
RHS is different, isn't it? There is one additional term over there. What is that additional term? Y raised to
n.
Yeah. Now here n belongs to the set of real numbers but is not equal to 0. The way this is written means it excludes 0. That is the meaning of this symbol. Okay, that is the way we write it. So belongs to set of real numbers but is not equal to 0. Remember that. If it is equal to 0, then it becomes Leibniz form, right? So there's no point. Okay, so this type of the equation, it is called as Bernoulli's differential equation. Now the question is, how do we solve it? We reduce it to this form. And then we solve it in the usual way by finding out the integrating factor and all that, okay? So for reducing it, what do we do? For reducing it, what do? We divide both the sides by y raised to n. Is it visible on the screen or what to you? Is it visible? Students?
Yes, ma'am. Yes, ma'am.
So we divide both the sides by y raised to n. If you divide both the sides by y raised to n, this is what you will get. Okay, and after that, what you have to do? Now this you need not do all this. See, multiply by 1 minus n to both the sides and all, you need not do. you can directly go to this step where you can directly make this substitution. Put y raised to 1 minus n as v, and then you differentiate and all that. Change the variable and substitute. I will just show you on a new screen. Just give me a minute. See, this is our Bernoulli's equation. dy by dx plus py is equal to qy raised to n. Now we are trying to make this to this form. Remember, we want it to be this way. Why we want it to be this way? So that once again we can find the integrating factor and all that and solve. So we'll divide throughout by y raised to n, means I will get y raised to minus n dy by dx plus p into y raised to 1 minus n, like this way, is equal to q. Followed out what I did. And now at this step, what I will do, let y raised to 1 minus n, suppose it is equal to v. Now I will differentiate. So if I differentiate using your normal derivatives, isn't it? So this will become 1 minus n y raised to minus n is equal to dv by dx. Are you following or what, students?
Yes, ma'am.
So now I will make the changes. I will use all this in this original equation. Okay. Now from this, what I can write, y raised to minus n dy by dx is equal to 1 upon 1 minus n into dy by dx. Okay. And now I will substitute here. So this equation will become 1 upon 1 minus n dv by dx plus pv is equal to q. And now what I can do, I can write this as dv by dx plus p, okay, into 1 minus n v is equal to q into 1 minus n. And remember, n is a real number, but it excludes 0. So 0 is not included in that set. Now over here you can see, is this looking in this form? Just tell me. Remember, this is a constant. So basically q can be a constant or it can be a function of x. So have we got the required form? Yes or no?
Yes.
Have we got the required form? We have got the required form. So now I'll just go back to the slide over here. Now here you can see, you can just see over here all these things. We got this equation, what I showed you after working it out. Now we will find integrating factor. Once again, e raised to integration p dx means we are going to take this whole term as p. So e raised to 1 minus n into p dx, whatever it is. And then we will use this formula. Okay, formula in this case will be, now the equation is in terms of v and x. So if the equation is like this, dv by dx plus this, just tell me which is the independent variable and which is the dependent variable in this equation. We have got the equation in v and x, which is dependent and which is independent. Can you tell me? Which variable is dependent and independent? Very easy question I've asked you.
Independent is x.
Independent is x, yes. And which is the dependent variable?
V.
V is the dependent variable. So earlier we used to put y into dependent variable into integrating factor. So here is equal to, so here we are putting v into integrating factor is equal to integration q into integrating factor plus c. Now this is just the theory. So whatever it is, you will integrate. So next time we will see this, the sum which is based upon this Bernoulli's differential equation. Okay, students, clear everything? Some part at least understood. So which is the most important thing in solving the differential equation? Tell me. Let me see your understanding.
Ma'am, integration.
Very good. You must be very, very comfortable with integration. That is one of the prerequisites of this particular chapter. So you should be able to integrate properly. Okay, I will, sir has come. So I will just hand over the host controls to him and then I will leave. Okay. So thank you, cadets. Have a nice day. Thank you very much.
Thank you so much, ma'am.
Yeah.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am. Jai Hind, ma'am.
Jai Hind. Sir, sing, sir. Is he there? Let me just transfer host control. Sir, you're there? Singh sir?
Yeah. Yeah. Good afternoon, ma'am.
Yeah, good afternoon. I'll just transfer the host control to you.
Okay, ma'am.
Yeah.
There is 2 batch combined over.
Yes, so one batch will leave.
Okay.
Division 3 will leave. Division 2 will stay. Division 3 can go back to their other class.
Okay.
Yeah, because Zoshi madam is on leave, so I had to sort of make this arrangement.
Okay, ma'am.
Okay. Thank you, sir. I'll take your leave, sir. Have a nice day.
Okay, same to you, ma'am.
Yeah.
So, good afternoon, everyone.
Good afternoon, sir.
Good afternoon.
Afternoon, sir.
So,
Good afternoon, sir.
okay, good afternoon. Actually, T6, how to get contact there? Okay, no problem. So, I think I am taking your class for first time.
Yes, sir.
Okay, so I am going to take your subject marine power generation and distribution. So the power generation part will be taken by me, and distribution part will be taken by Gajan sir, but he is on leave, so from next week he will take your classes. Okay. So by any chance, if any one of you can message some this group 1 also to join us in this class, so we can take combined class. Because Gajan sir is not there, so his class is there and it will go vacant. You know the guys from group 1?
Excuse me, sir, can you please be a little louder?
If you guys have contact with the group 1, like you are group 2, no?
Yes, yes.
In division 2. So can if you have contact with division 1 guys, can you tell them to join this particular class so we will have combined class?
Okay, sir. Okay.
So till the time, just circulate this message. If they can join, then it will be good because Gajan sir is not there, so I will take his class also. And meanwhile, I will okay, I will start teaching straight away. But if you guys feel anything you don't understand, and anything if I ask you and if you don't know, don't hesitate. Whatever you know, you can tell me. If it is wrong, I will correct it. But I will not mind that you don't know about that. Okay, I will not judge you. I just want to know how much you know so I can start. Okay. And one more thing, just try to interact a little bit, because if you don't interact, then this classes will be little very bore. And if it is bore, I will also not enjoy to teach you, and you will also not enjoy the class. Okay. So better to make it a little bit more interactive. Okay. So our subject is marine power. So what is marine? I think everybody knows. Power is also, I think everybody knows. Generation is also, I think everyone knows. Then you will say, sir, then why you are teaching everything? We know everything then. So small introduction about power. What is power?
Sir, can you speak please a bit louder?
Okay, okay, I will. Now you can hear me clearly?
Yes, sir. Yes, sir. Yes, sir.
Okay. So can you tell me what is power? Anyone? Electrical power. I'm not talking about others. I'm talking about electrical. Electrical power. Anyone? I will change the settings so everybody can join properly. You can see this. Okay, so now everybody can join. No need to wait in outside. You can unmute yourself, rename yourself, start video, share screen.
Excuse me, sir.
Yeah,
Sir, will you please check the waiting room? Many students are there.
I have disabled the waiting room, so now they can join straight away. Okay.
Okay, sir.
So now I will start again. So I was asking, what is power? Electrical power. Any views, any thoughts on this? Energy used in per unit time. That is called power, no?
This is mechanical power.
Yeah, but the same thing like in electrical also. What you are using electrical energy, but you are using in respect to time or respect to like kilowatt hour. This is the unit what you are paying at your home, no? Electric meter. So it is also measuring how many kilowatts you have used in 1 hour. In 1 hour. So according to 1 kilowatt hour is 1 unit. If you are using 2 kilowatt, then 2 units. Okay, in 1 hour. Understood? And if you talk about the electrical power, so we can say the electrical power is defined. If you say the formula is P is equal to under root 3 VI cos phi. I think this formula you have studied in previous semesters. You're familiar with this formula?
No, sir.
No. Okay. No problem. Okay. No issues. So we will talk about this. So now I think you know familiar with this one, no? V is equal to IR. I think
Yes, sir.
6th class we are reading this one and you are studying this one. So this formula is applicable for what kind of power circuits? AC power.
Sir, that root 3 VI cos phi is in three-phase power, na?
Yeah. So this V is equal to IR is applicable for AC power supply or DC power supply?
DC.
DC, very good. So it is for the DC. So if I talk about the power in DC, so you can say P is equal to V into I is a power. Okay. And also you can say, okay, V is equal, if you replace this one, then you can also say that, okay, V square by R and I square by I square into R, whatever you like, you can name it. But this is for the DC circuits. Okay. It is not applicable for AC circuits. Why? Any idea? Because in DC circuits, current is constant. It is constant or it's changing?
Constant.
Current is constant.
Voltage is also constant. So when you have constant voltage and constant current, then your power is also constant. So this cos factor is 1. Why? Because in DC circuits, what we see that the voltage and current, they are in same phase. So there is no angle between them. So angle between them is 0. Cos 0 is 1. So that's why we don't write over here. Okay. This cos phi we used to write only in AC circuits. Why we used to write in AC circuits? Because in AC circuits, this voltage and current differs as per the load. So if you talk about resistive load, they are having different type of phasor diagram. And if you talk about the capacitive load, they have different type of phasor diagram. Okay. Anyone has the issue with these terms also?
No, sir.
You understand, no? So if you have resistive load, so resistive load is having voltage and current in same phase. Okay. When inductive load, the voltage is leading. Okay, by phi, this phi angle, and current is lagging. And in capacitive type of load, current is leading and voltage is lagging. Okay, VC. That's why this phi angle is this one. So with this phi angle, you can determine what is your cos phi. That's also called power factor. So anyone knows about power factor, what it is, why it is important, why we are studying about it, what is the practical importance of this particular thing? Any idea? Are say yes or no?
No, sir.
Yes, sir.
Yes.
No, sir.
So what you know about that? The guy who said yes, please elaborate what you understand by power factor. Okay, don't worry. Like what is power factor is like maybe just with an example we will understand this. Okay, so everybody used to go to some shops or some clubs or something. So there used to go, you used to go and order some maybe some soda or something. So when you are ordering the soda, you have ordered soda, which is you have ordered maybe one glass. So you are paying for this much capacity of soda. This is a full capacity of soda. This is a full capacity of glass, and you are paying for this one. But whenever the waiter or bartender is giving you the same thing, you will see the lots of foams are there. These foamy matters are there. So you can drink only this much. Understood? So this is in power in the field of electrically, you can say this is your apparent energy. Means this much energy you have to get, but you are getting only this much energy. That is called real energy, real power. This is called apparent power, and this is called reactive power. Reactive power. Okay, so this foamy matter is a loss for you guys. Why? Because you are paying for this full glass and you are getting only this much. This much is a loss for you, and that is a gain for maybe the hotel guy. But in the power triangle also, if you see, I think you have seen this power triangle in maybe in your school also. So this is your apparent power. What is apparent power? I will explain you a little bit in detail. Okay. So that is your apparent power. This is the real power what you are consuming. And this is your reactive power. Okay. And this angle is called phi. So when somebody is asked about power factor, what is power factor? You can say the ratio between real power upon apparent power. That is a power factor. Okay. What is apparent power? Like if you, I think everybody knows about the transformer, no? The transformer is having one primary winding, and then it is having one secondary winding. You know about this, no?
Yes, sir.
So if your 220 volt input is given, which is having 2 ampere, okay, and the output is 440 volts, how much the current will be there in secondary side? Any idea?
4 ampere.
4 ampere. 1 ampere.
1 ampere. 1 ampere.
Why it is 1 ampere? Because you always see the transformer never generate any power. It only transfers the power. So if you see the power over here is 220 into 2, 440 volt ampere. Okay. The same you will see over here 440 you had already. So only 1 ampere should be here. So that's why this both are same equal. Understood? So this is an apparent power because this transformer is transforming this power from this primary winding to secondary winding, and this is the apparent power. And when you will connect some load over here, that load is having some type of maybe it consists of resistive type load, maybe placed with they have inductive type of load, maybe they have capacitive type of load. According to this load characteristics, the power factor will change. Why it will change? Because when the current will start flowing in this one, maybe if it is resistive type of load, it will be in same phase, so cos factor will be 1. But if it is having the inductive type of load, it will have this cos phi of power factor less than 1, because current is started lagging, okay, and voltage is leading in this kind of systems. And in capacitive, the current will lead and voltage will lag. So in this, this is for the capacitor, it will be more than 1, and for the inductor it will be less than 1. Okay, understood? So there is one question everybody used to ask, why we are giving all the ratings like transformer rating and generator rating in kVA, kVA or MVA, sorry, MVA, wait, too much. So why we are using like this? Because this resolution plan is not good. Wait. So why we are using this? Because if these are kVA, MVA, these are the rating you will find on board also and ashore also. All the power sources are given in this particular form, because this is an active power supply. All the equipment, electrical equipment which are providing the power, they are active elements, active power supplies. Okay, so they don't have any consumable or any power consumption inside them. So that's why they don't have any power factor. So if they don't have any power factor, that will be represented in VA form. And if it is having power factor, then it will become to change to kilowatt or megawatt. Understood? समझ में आया? Any doubts?
Yes, sir.
Yeah, what? Ask. What did you understand?
Sir, can you please explain the last thing? KVA and KW.
Okay, I will explain again. In previous example, I was telling you that 440 volt ampere was the power transmission capability of that particular transformer. Okay, why we are talking in volt ampere? Because we are providing voltage and the current it can take and voltage it can take, and the same amount of voltage and current it can be step up also, step down also, but the power rating will be the same. It will never be like more or less, it will be same. But when we talk about the motors, or when we talk about heaters, or maybe we will talk about any electrical appliances. So what happened in electrical appliances? All the electrical appliances are consist of, maybe if we talk about the motor, so motor is made out of inductors. Lots of inductor coils are there. Okay, so the transformer is active, so active component. Why active component? Because it is providing power, but it is not using that power for itself. It is providing that power for other devices to run. And these things are, all the appliances are passive elements, passive components. So these components will use this particular active power. Whatever is provided by active power is used by these. Understood? So all these appliances are made of only these kind of supplies, like these kind of load. Maybe it is resistive load, maybe it can be inductive load, maybe it can be capacitive load, or maybe it is combined with resistance and inductor, maybe resistance and capacitance, maybe all these three. Understood? So when these loads are having when this load is consuming power, it will have phasor difference between voltage and current. Okay, like in case of conductor, in the case of inductor, I was telling you that the voltage will lead and current will lag. So this phi angle will be there. So only in the passive components they have this phi angle, means the angle between voltage and current. So that is from if they have like this, then only we talk about the cos phi power factor, because this is a cos angle. We are taking this angle and we are taking the cos of this angle, and then in the same thing we are using in this formula. So if we talk about the single phase power supply, we have to use cos phi, because this voltage is leading and this current is lagging. To understand it more better, just to have little bit more idea, I will explain you. Now you understood it, or I need to explain a little bit more further? Anyone who didn't understand? Understood? So
Yes, sir, understood.
okay, so when we talk about the AC power supply, only for the passive components they have all these type of loads, and when they have this kind of load, they have these kind of angle. The phi difference is there, the cos factor will be there, and with this cos factor, power is changed. So when all the active components, they can supply voltage, they can supply transmit the power in voltage ampere form. Okay, voltage ampere, kVA, kilovolt ampere, MVA, megavolt ampere. And when we talk about the passive component, because it is having phasor angle difference, and it is a combination of active power and reactive power, so it will be mentioned in kilowatt, megawatt. Understood? Understood?
Yes, sir.
Okay, so now we will do one small exercise. So you will have little bit more idea, better idea about this. So for everyone note down this. I'm giving you one numerical that you have to run 1 kilowatt of electric kettle. I think everybody know about electric kettle. Nowadays it is very popular. You are having in your home also. And the power supply and the cost factor is 0.95 and voltage is 220 volt. The same in other system, 1 kilowatt of electric kettle, cos phi is 0.5 and voltage is 220 volt AC. Okay. So how much is the current in this condition? Find out the current in this condition and find out the current in this condition. I'm giving you 2 minute times. Just solve this one and tell me how much it should be.
Sir, Sagar Sawant is in waiting room. Will you please allow him?
Oh, it should be because I disabled the waiting room.
Okay, sir.
Yeah, Sagar Sawant is still in waiting room. Okay. Okay. So now two batches are combined, no? Group 1 and group 2, both are there. So how much should be the ampere for first case? What is the ampere for first case? Anyone?
सर पावर को किलोवाट में ही ले लेना।
हाँ किलो नो, पावर को वॉट पे चेंज करना पड़ेगा ना। 1 kilowatt is 1000 watt.
तो 4.78 आ रहा है फर्स्ट में।
4.78. Okay, and what about the second thing, second case? So in first case, you will get 4.78 ampere. That's really correct answer. And second case, I think you will get 9.09 9.09 something. Okay. So why
Yes,
I
sir.
was giving you this, because like in your home, you are using electric kettle. Okay. 1 kilowatt kettle. That load is fixed. This load is fixed for both. Only what is going to change? This factors are changing. Because of this, you can see that ampere is changing in huge amount. You can see the ampere from here to here is almost double. Understood? So plenty people used to say that, okay, I'm not using very huge amount of electricity, but my bill is coming very high. So in first case, when you're using 1 kilowatt, you will get maybe 1.1 unit. Okay. But in second case, when you're using 1 kilowatt of load, because of the bad power supply, it will consume 2.1 kilowatt, means 2.1 unit. So you are paying double for same amount of load what you are using if you have bad power supply. So तुम्हारे घर में किसी घर में if you have this issue that your electricity bill is coming more, load is not good, just go and buy power factor meter and check the power factor in your home. And if you found power factor is not good, you can complain to your respected power provider, because according to guideline they have to provide power which has to have power factor of 0.95. इससे नीचे आ रहा है complain करने का. What else you can do to improve power factor? Any ideas? Everybody understood what I was telling you about this? Any doubts? Any doubts till now? Why I am teaching this? Because power generation and distribution is little bit typical topic. And according to me, it should not be on first year, but no problem. If they have given you this syllabus, I will try to teach you as much I can. And I will try to make it simpler way as much as it can be. So you can understand it. If I don't tell you about these things, I will start telling you about what is alternator or how it works and how this all the things are going on, and you will be a little bit confused. So you got this point? Everybody understood this? Any doubts?
No, sir.
So to increase power factor, there is two methods. One method is what we can do. We can connect capacitor bank. Capacitor bank is like nowadays it is very popular in lots of small industries. So what they are doing here, they are connecting lots of capacitors together, and then they are connecting it to, they have capacitor like this. These two wires are there, no? So they are connecting it like this, and then they are putting that connection to the AC power supply. So why they are, what will happen after this? Because as I was telling you that in the phasor diagram you can see the capacitor current leads and voltage lags. So what happens when current leads? It will improve your power factor because capacitor is having power factor more than 1. So if your power factor is less to the supply, this will compensate the drop and it will try to make it more. So it can be improved to 1. Understood?
No, sir. Can you please repeat?
Like I was telling you about RLC circuit, no? How RLC circuit works.
Yes, sir.
So in RLC circuit, I told you that capacitor current is leading and voltage is lagging. So that's why it is having power factor more than 1. So if you are having inductor type of load, this current is lagging. Lagging means current will flow after the voltage will flow, and leading means voltage or current that will flow first and then the second will flow later. So wait, I will explain you a little bit more better way. So like what happened in inductor, like you have this coil, okay, and this is capacitor. So what is the difference between these two? Any idea why capacitor? What is the difference between these two, and why this resistor? If we see in the resistor, we are saying that current and voltage is in same phase, but in these two it is different. Why it is the case? Why it is so? Any ideas?
No, sir.
Yes. Yes, go ahead. Actually, if you see in capacitor, we are storing what? Charges, no?
Charges.
So that is called electrostatic. Because it is having static charges inside. Okay. And this is also storing energy. These capacitor and inductor, they both have this property that they can store energy inside them. So this is storing energy in form of charges, and this is storing energy in form of field. Understand? So that's why it is electrostatic and this is electromagnetic. Okay, understood? इतना समझ में आया तुम लोगों को?
Yes, sir.
Yes, sir.
Yes, sir.
So what happened when you provide voltage in this one and in this one? So what happened? This capacitor is already charged before only. So even you didn't provide the voltage, the current will start flowing by itself only. As soon as you close the circuit, it will start flowing because this capacitor will discharge. Understood? So capacitor, this current will start flowing, and after that, this voltage will start coming back. So current will lead and voltage will lag. So when the current start flowing, then back to again this voltage will go and charge this capacitor, then again it will discharge, and the same cycle will go on. Okay. So now you understand why this current is leading in this particular capacitance type of load. Understood?
Yes, sir.
In this, what happened when you are giving voltage? So it doesn't have any charge inside, but what it has, it is storing that voltage as a form of field. It is creating electromagnetic field. This field is getting created. Okay. So when this field is getting created, so this charge is this current is consumed and it is stored in form of the field. When you are again supplying more current, more voltage, then what happens? This load will only withdraw the current when this field is discharged, or maybe this field is in contact with other field. Okay, so like I connect one more coil. So this coil will have these two coil have mutual induction, and then this particular VL voltage what you are supplying, with that this field has been created and mutual induction, and after that this EMF will start flowing over here. Understood? So in this, the voltage is flowing first. Voltage is a cause, and current is a action. So that's why in inductor voltage is leading and current is lagging. Understood?
Yes, sir.
And in resistance, as soon as you provide voltage, the current will also start flowing. So that's why it is having power factor 1. Okay. So when you will read RLC circuits, I think you have in your previous semester.
No, sir.
Okay, maybe in this semester they will teach you. So you will see that there is one resonance condition. In resonance condition, what happens? We are talking about this particular thing. Then when all the circuit means which is having combination of R, L, C component, it will when it will act like a resistance. That is a resonance condition. So just to have understanding about this, only these things you have to know that okay, how this inductor is storing energy and how this capacitor is storing energy and why this is always why this is giving more power factor and why it is giving less power factor. So just in case when my power supply is having less power factor, so now when I connect lots of capacitors together, so my capacitor will start giving current and then that current will improve this power factor. Understood? समझ में आया?
Yes, sir.
Out of sight, yeah, I will repeat, but just you ask the questions here. Like I told you, capacitor is the current is leading. The current is just to understand. My power factor is less. Okay, so just to understand, I have x plus x1 plus x2. So if x1 is 0.5, and if I want to make my resultant maybe 1 or maybe 0.01, so what I have to add over here? I have to add something which is having the value more than 1. That's correct or not? Understood? So if I add 1.06, so then I will get this particular amount. समझ में आया?
Yes, sir.
So now for this x2, only I get 1.06 value of more than one value when I use capacitive type capacitive type of load. So now I am using capacitive bank. Why we are calling it capacitive bank? Because we are connecting very large amount of capacitor together and connecting it to the power supply. Understood?
Yes, sir.
So now I think
Yes,
it's
sir.
clear.
Yes, sir. It is clear.
Okay, second type of thing we can use is synchronous motor. I know lots of you guys have heard about it and maybe some of you guys know about it. I'm not going to cover it. I'm just giving you small idea that in synchronous motor also we can improve power factor more than 1. Okay. So in big industries, like if you see very big industry, Tata Motors and all the big industries, if they are having very big motors to drive, they always put one synchronous motor together with the power supply to increase power factor. Okay, because when power factor is less, you consume more power. Okay, understood? Means more power is like you are having more losses. So the power amount, the quantity of power you are using more, but the efficiency is less. So to improve the efficiency, you have to improve power factor. Okay, understood?
Yes, sir.
Okay, so now I will ask some question from you guys, and this is in this way I can take attendance also, and I will have some idea also where you guys from. So now I want to know that we are generating marine power or whatever you think that we are generating power on board. So why we are using for what we are using all this power? So what are the things? What are the components? What are the machinery we are driving with this particular power? Okay. So Abhishek Kumar, tell me one machinery which is driven by this electrical power on board ships or one system. अभिषेक कुमार लॉगिन करके भाग गया. Who is CR?
Sir Pratham.
Note down his number. Afterwards, give me his number. I will make sure that he has to attend the class from next time. So you guys are not in campus, or you are where you are now?
We are in campus.
Okay, that's why I can see this picture of this garden, Harsh, yeah, or something. Okay.
Yes,
So
sir.
maybe next month your offline classes will be started. Then it will be a little bit more better. Just remind me about this Abhishek Kumar. उसको बताऊंगा वहाँ पे.
But sir, until 23rd March, we have our practical.
Okay, you are there for the practicals only.
Yeah.
Then you will go back.
No, sir.
Okay, we'll see what happens. No problem. Okay, Adarsh
Yes.
Yadav. Why we use electrical power on board?
Sir, to the machineries.
To run machinery. Which kind of machinery?
Sir, lathe.
Lathe. Okay. Okay, good. Next one. Adhiraj Singh. Adhiraj Singh is also not there. Aditya Srivastav, 005 and 001. Okay, wait, I will note it down. Aditya Srivastav. He is also not there. Very good. So, very good, very good. This is very good now. First year, and they started bunking. 001, 005, 007. Okay. Aditya Srivastav, 06, sorry. Akash.
Yes, sir.
Tell me any machinery which use electrical power on board.
Electrical power on board. Drilling machine, sir.
Drilling machine. Very good. Okay. 008. 009. Akshat. Akshat Hukmani.
Yes, sir.
Yes. Same question. I don't have to repeat again and again.
So generators?
Generators. So generator is consuming electrical power.
Excuse me, sir.
Yeah.
Sir, I'm Aditya Srivastav, 005. 006, sir.
What happened? Where were you?
Sir, actually, my mic was not. I am unable to unmute, sir.
Okay, now you can unmute. Okay.
Yes, sir. Can I answer?
Yeah, you can.
Okay, sir. Sir, wait, let me. Sir, sir, kitchen appliances on board ship.
What are the appliances there?
Sir, ovens, chimneys, refrigerators.
Okay. Okay, and where is this guy? 009?
Excuse me, sir. Yes, sir.
Yes.
Sir, 001 Abhishek Kumar. Sir, actually, so my line was not working. So it is breaking in between.
You see, all of a sudden your line started working. So very good. No problem. Anyways, I have sent your name to Kanwu, sir, so he will come back to you. Don't try to bunk the classes from now on, because then you will say, sir, I was having this problem and we will not going to cover the basic again and again for you only. We don't want to waste time of others because of you. And if you don't want to study, that is up to you. I have to just report it that this guy who don't want to study. That's it. Okay. Tell me the answer if you know.
Yes, sir.
Tell me.
Sir, fridge.
Fridge. And what? Only fridge you are using on board.
Sir, pumps.
You are not Abhishek.
Sorry,
Just
sir.
wait for your turn.
Sir, lathe machines.
It's already said. It's already told by, I think, by others.
Sir, drill machine.
It's already. You are sleeping or what? You're not there in the class only. Your friends have messaged you though you are not there, sir is asking for you. Then you all of a sudden you joined and you think, okay, now I can balance. What I was teaching before? What is power factor? Again, your LAN is gone bad.
No, sir, it's working.
Then tell me what is it? What it is? From 2 years, you are making fool to everyone that you are attending class and you are doing whatever you want, and then also the government is helping you to pass you anyways, and then you think that you are a smart guy. That will not work in real life. You can pass the exams, you can keep your certificate with you, but that will not solve. That will not help you to solve any real life problems. समझा? Anyways, I have given you name, so no problem. Who else is not there in my class? Don't worry. They will. The institute will get back to you and they will tell you how this system works. Okay. Others, I know that you are not there. Don't waste time of others. Okay, Akshat Ukmani.
Sir.
Yeah, where are you from, Akshat?
Sorry, sir.
Where are you from?
I'm from Pune.
Pune. So I am asking about the consumable, the electrical power consumers, not generators. Do you know all the machineries or any machinery on board which use electrical power?
Sir, drill machine and lathe machine, milling machine.
Where you get all these ideas? Means who told you about these things? What do you think that in onboard ships everybody is doing drilling and everybody is doing this? They are running lathe. It is happening.
So pumps, fan, light.
Yeah, you can say all these things, but now you are getting the ideas. But just keep this in mind: lathe and drill machine is not a machinery. They are auxiliary machinery. They are used sometime if they have some issues. We don't have some spares, so we can make in lathe, or maybe maximum they are used only for cleaning purpose and small jobs. Okay, so pumps is the answer, but the thing is, you have to understand pump is a mechanical part. Motors are the electrical part. The motors are driven by the electrical power, which is in turn driving the mechanical power. Understood?
Yes, sir.
Okay, Akshay. Akshay Vinod.
Yes, sir. Hello.
What else?
Computer.
Huh? What else?
Computers.
Computers. Okay, good. Computers. Aman Godra, where are you from, Akshay?
I'm from Kerala. Sir.
Kerala. Okay, good. Aman Godara.
Yes, sir.
Where are you from, beta?
Sir, I'm from Rajasthan, sir.
Okay. Which components which things we used to run with electrical power?
Sorry, sir. Sir, your voice was breaking, sir.
My question is same what was before. Do you know?
Yes, sir.
Yeah. So just reply what is answer. Okay, it will take way too much time.
Sir, various machineries and navigation devices and
No, various machineries. What? That is I'm asking. Okay, I'm telling you one by one, but you don't have to remember this thing just to have understand about the idea. So this is this kind of ship structure as I think you have seen. ऐसा होता है ना कुछ ship. यहाँ पे main engine होता है. This is your propeller. This is your accommodation. they have this mast. Okay, so from ये forward mast, so from here to here, all the पूरे area में everywhere you are using electrical power. You are using electrical power for lighting because everywhere you need light. Without light, you cannot able to work. No, चलेगा? No. You need electrical power for navigation also. In navigation, you need for navigation lights, for navigation equipments like radar, ACDIS. Okay. Then you need for VDR, all the navigation equipments, more than 20 navigation equipments are there, which is using electrical power all the time. Then after this, you need galley. Galley is there, no? So in galley, you have various type of equipment as someone has told, refrigerator, hot plate. Hot plate is a cooking plate, oven,
Washing
fryer,
machine.
grinder, that is different, and grinder and all. Okay, so they have more than 15 types of machinery, different machinery in galley, which is used for power cooking. Then if you go in deck, you will find lots of deck machineries like winches. You have to bring your ship near and far, no? So how you are bringing it with the help of winches, electrical winches. That is also called mooring winch, anchor winch. So on the deck, you are using for winches, you are using for crane, you are using for cargo handling operation. Like if you are using for to bringing up and down, there is some pilot ladder is over here. With the pilot ladder, you can bring this ladder up and down. So this ruler is there. So you have small motor to bring this ladder up and down. So for all this thing, you are using electrical power. Okay. And on deck also you have lots of ballast tanks. Ballast tanks are the tanks where you are keeping lots of water inside to balance your ship, to make it more stable. So all these ballast tanks are filled up with the water. So that water is supplied by the ballast pump, and that ballast pump is having motor. So all these motors are there. Plenty motors are there. More than 100 motors you can find on board, which is used for different purpose. Okay. So if you see in on board, 60% equipment is electrical driven. Okay. Only the main engine is not electrical driven. And in some cases, if you go in some good companies, they will find that along with the main engine, they have this electrical motor also. So you can drive your propulsion system also with motor. Okay. Rest everything is electrical driven. Not a single thing is mechanically driven or something. Only in tanker, if you go, they have COPD system. So in COPD, that is turbine operated your pump. So that pump is using steam. So that is different. But in normal ships, you will see all the equipments are running with the electrical power only. Understood? So if you want to name it, it is so much that you can name maybe for 26, 36 hours. So many equipments are there. समझ में आया?
Yes, sir.
Yes, sir. So plenty equipments are there. And why we are studying about this, that we have to understand what is the working of generation system, how the generation systems are generating power, how it is getting consumed. If something is taking more power, what should be the reason? How we can detect the faulty equipments, how we can repair it. So all the things are there, and you have to understand it. So don't read and don't mug it up everything. Just try to understand. If you understand something, you will never forget. But if you are just mugging up everything, you are just studying only for passing the exam. That is very bad attitude. That will not help you in long run. Okay. So 5 minutes are there. And actually, I don't want to teach for a very long time. I used to teach only for 30-35 minutes only. 10-15 minutes, I want to do some discussions with you guys to understand how you understanding the things. ऐसे मेरे को आके lecture देना है, and after giving lecture I can go, but I think you will not understand anything with that. When you will discuss the same thing, then I will also understand how you're understanding it, and other will also get benefit from that, that they will also have little bit better understanding about the same thing. Okay, so in this class, you guys have any doubts? Anything you didn't understand what I have explained? Indrajit? Indrajit? Indrajit.
Yes, sir. Am I audible?
Yeah, you are. Any doubts, Inder?
No, sir.
Okay, good. So you want okay, next class I think I have next week, but till that time I will tell you guys better to start studying about these things, and the books I'm recommending for this particular topic is DT Hall. So you don't need to buy that book. I will send you the soft copy of that book, so you can read from there, and if you want to buy it, that is your choice. And the second book is Fernandez, that is also good for this particular subject. But the thing is, you will never find all the information in one book. You have to look in something in this book, something in that book. So so the best book what I can recommend is DT Hall, Dennis T Hall. So don't worry, I will put that book in that first year group. I think you guys are there, or maybe I will make some. I will send to some guy, and you can forward amongst you each other. So that book is really good, and that book will give you a really good idea about ship also, that how the systems are there, and how I will teach you. No doubt, I will tell you each and everything, but I will tell you guys to better to read that, and if you have any doubt, then we will discuss that, and I will clear it. So then you will understand that particular topic also really good, and then you don't have any problem in understanding the systems what I am going to teach, or maybe what systems you are seeing it for first time also, you will have better understanding about that. Okay, so I'm writing the name of the book in this particular chat box, so everybody can. Danish T Hall. Okay, I will send you the soft copy. Okay. So okay, so any doubts?
Thank you, sir.
Yeah, I know everybody is very happy that I'm leaving early. And about Abhishek Kumar, you are there?
Yes, sir.
Just consider this one is as a first and last warning. Next time, don't do like that.
Yes, sir.
Okay. Okay, so everyone, I'm leaving the class. So,
Sir?
yeah.
Sujata, sir.
Yes, ma'am.
Yeah, you make me host and then you leave the class.
Okay, okay, ma'am. Okay.
Yeah. Thank you.
Okay, ma'am. So now you are the host. Okay.
Yeah. Thank you, sir.
Okay, ma'am. Thank you. Okay, bye, everyone.
Thank you, sir.
Okay, so I want only div 2 over here. I think 2 divisions are there, right?
Yes, ma'am.
Yeah. So which is the second division?
Division 1, ma'am.
Div 1. So you might be having some other class, right? Yes or no? My class is not there. My class is only for division 2. Yes, Akshay?
Ma'am, they are leaving.
They are leaving. Good. Chalo. Let them leave. After one or 2 minutes, we'll start. I think only division 2 is there now, correct?
No, ma'am. No, ma'am.
And they also there.
What? I want only division 2 students over here.
Ma'am, you can remove, ma'am.
Why you cannot leave?
Can you give us?
No, I'm not going to give you any time because 4 to 5 lecture will be there and then you are going to have break. What's the problem? But I am not able to understand. Only 2 students will be over here.
Ma'am, please make course to the CR. He will manage everything.
Yes, ma'am.
Why you cannot? You just gave me answer to my question. You cannot leave or what?
Ma'am, but I am from division 2. How can I leave the meeting?
I am not saying division 2 should leave. I am just saying other division should leave. Why division 2 will leave?
Ma'am, I am Dhruv Tyagi.
Yes, Dhruv. Acha, who is division 2 CR?
064 Animesh.
Animesh, listen what I'm saying. Just take the list and tell me whether div 2 cadets are over here. No, any other cadet. Do you know your division list is with you? You know your friends?
Yes, ma'am.
Let's check it once.
Himanshu and Jana leave the class.
Jaipa, please leave. Hisham.
Ma'am, 4 are extra.
4 are extra. Who are they?
Adarsh Yadav.
Adarsh Yadav. Just
Sagar Sawant.
वो सो गया होगा. उसको पता ही नहीं है.
और ये सागर
Hunar.
Himanshu and Jana leave the class.
Yadav, leave, please.
तो मैं ना आदर्श यादव को रिमूव करती हूँ.
Hisham.
एक मिनट. हाँ, केशव.
मैम हर्ष यादव.
1-2 मिनट. One at a time. केशव.
मैम ध्रुव तागी. Hisham. परेशान बैठो ना.
नंबर बोलो. नंबर बोलो.
Okay, ma'am. 074. Ma'am 078. 170.
एक मिनट. 078 प्रथम क्या है?
Ma'am, I am from division 2.
Ma'am, listen to me. Ma'am, I am CR. Listen to me.
हाँ.
170.
182. 170. Just a moment.
113.
रुक 2 minutes.
Yes, ma'am.
170. Why I am not able to get it now? Yeah, Sagar Sawant.
Yes.
Yeah, I removed him.
113.
113.
Yes, ma'am.
Yeah.
049 also. Done, ma'am.
Done, no?
Yes, ma'am.
Okay, fine. 049.
No, ma'am, I am from division 2.
I know. So I'm going to listen to only your CR. Okay, ठीक है. So now, CR, I forgot your name, please.
Animesh Karge. Prathamesh Jadhav. 064 Animesh.
Animesh, all division 2 cadets are now over here, right?
Yes, ma'am.
Done. Okay. And don't do all these things with me. Keep in your mind. You are first year cadet. I am from last near about 15-16 years over here in Tolani. And you don't know, I don't want to tell you what I am. I'm not interested in that. Definitely. It should be in positive sense, not in the negative sense. I should do all these things. But even if it will be offline class, my class, if you'll do all these things, you don't know what are the things I can go for. So itna time pass wala cheez mere class mein bilkul nahi karna hai. The one who are doing, right? This is first lecture. From bottom of my heart, I'm telling you, I just don't like all these things. you doing this thing and then I'm punishing you and all and this and that. I am not interested in that. Keep in your mind, right? हाँ बिल्कुल पढ़ाई वाली बात करेंगे. कुछ डाउट है तो आई एम देयर, राइट? आपके डाउट्स क्लियर करना, आपको हेल्प करना. फॉर दैट यू आस्क any of your seniors, right? How I used to handle the subject and the cadets also, है ना? एक 5-10 दिन दो मुझे, I'll be able to know by your name. तो ये सारा चीज मेरे साथ बिल्कुल मत करना. फर्स्ट एंड लास्ट वार्निंग. इसके बाद एंड डेफिनेटली डे 1 2 ऐसे होते हैं कि उनसे बहुत ज्यादा एक्सपेक्टेशन, पता नहीं मेरा यही प्रॉब्लम है, शायद हो जाता है, बट मेरा एक्सपेक्टेशन बढ़ जाता है. इफ यू डू दिस थिंग, नो, इट जस्ट डिस्टर्ब्स, नथिंग एल्स. वेट, लेट मी शेयर, फिनिश. ये एक बात खत्म हो गई यहाँ पे. Whether you are able to see the whiteboard?
Yes, ma'am.
Yeah.
Yes, ma'am. Yes, ma'am.
Yeah. And you keep on talking with me. I just love this thing. कि आप मुझसे बात करो, आप मुझे बोलो, आपके डाउट्स बोलो, आपको आंसर आता है बोलो. आई एम ऑलवेज देयर विथ यू फॉर दैट. एक्चुअली अगर आप नहीं करो तो मुझे प्रॉब्लम आती है. मैं आई कैन नॉट टीच लाइक दैट. ओके, आई एम सेइंग आई तो लेट मी स्विच ऑन. एक थोड़ी देर के लिए वीडियो ऑन करूंगी. सो यू शुड नो माय आई मीन by face you should know me. Why I'll tell you, because yesterday I was there in the, actually I'm taking 2. Okay, wait, let me start the video. एक minute, you are not able to see. I will just change the, you are able to see me, right?
Yes, ma'am.
What happened is, actually I'm taking 2 subjects, one for your class and your year, first year, and another one is for second year. So I'm taking actually 2 subjects. Reason is also behind that, and I'm going to tell you what is the reason. I want to tell you because for you only, for you and for your subject, actually I am over here. So what happened is, yesterday I visited this workshop, and some of the students were on late second year, and just to know, right? I asked one of the students which subject I take and who I am, rather. So he failed, and he told me some other name, some other subject also. So this is very bad, है ना? So that's why you can see who I am. Right, I'll give you my name and all those things, definitely, with whom I'm sharing and why I'm over here. Okay. So myself, Sujata Gangadmale. Okay, I'm from Maharashtra, Pune, and I'm area chair of electrical. जैसे दूसरे कॉलेजेस में होता है ना, HOD, on the same line. I'm area chair for electrical. Then, so if you are having any problem related to the subject, the practicals going on, or your suggestions, anything and everything related to electrical and electronics, right? Welcome. You know my number. My number is there on the group. So, and if you want, I'll write it over here also. Right, WhatsApp पे भी same number है. आपको कुछ भी query है, I'm there for you to solve it, right? Then actually from 2006 onwards, BITS was there. Then IMU came. I think till 2017 batch, I was there for BEEE. अभी ये तो आपका BEE है, but at that time it was BEEE. Okay, and I took this subject, but then, I mean, not for, I mean, because my BE and ME is in instrumentation, process instrumentation, control. And control. So I should be there on control side, because actually I'm not electrical faculty, है ना? So I should not be over here, but because of some of the reasons I was there. And don't worry, I'm having enough experience to take BEEE also, so no need to worry for that. I'm going to take your BEE. but I was taking control, right? 17 onwards, and I was taking AAMC. I am taking, still I'm taking, no? So it is Applied Marine Control and Automation. I'll be there for you also in second year, right? So this subject I was taking, but what happened, not suddenly, because of this COVID situation, actually, I'm telling you why I'm over here, right, for BEEE. So what happened is, we were thinking how to go for the practicals. Theory is okay, we are doing online, everything is okay, and आपको आएगा experience. Tolani ke faculty are best. I'm not talking about me, right? I'm talking about all faculties, 99%, including lady faculty and gents faculty, both, right? They are very nice. I mean, they are very nice. So online lectures were going on very correctly. We searched a lot for that also. Theoretically, kaise padhana, like you can see, I'm using XP Pen, right? All these previously we were zero in all these things because only offline lectures were there. We were never many of us, I said all, right? We never took any online lecture before, so we were zero in Zoom and all those things. So we found out all these things, XP Pen and many. You cannot imagine starting May when I was not aware of XP Pen on this phone, right? आपका जो mobile होता है, on this. My daughters prepared one pen, right? Because my subjects are always design wale subjects. So I'm supposed to solve n number of numericals, and I don't believe in, I don't know, many of the faculties are using PPT, but I don't believe in PPT and all. I think if I'm not writing, I'm showing you the data and I'm telling you to write or to solve, it is just a wrong thing. I should write, you should also write with me. That only will give you confidence कि हाँ मैडम कर रहे हैं, हमको भी करना है और हम भी कर सकते हैं, right? So on the phone I was trying to write, was very tough. So with that Lexi pen, right? We removed everything, my daughters. Then ये जो होता है earbud, वो उसमें डाला. With a wrapper of Cadbury का wrapper होता है ना, paper, aluminum foil, उसको लगाया उस पे, थोड़ा सा पानी में एकदम थोड़ा सा wait करके I used to take the lectures on phone. So first semester 2020 का we did this thing, and then after that, see, at that time I used to require 12 boards for a single lecture. Then saving those things, making PDF after the lecture, I used to share those things on Google Group to the students, was become a hectic thing. So then I come to know, yes, XP Pen. So I was the first one to use XP Pen in the college, right? मेरा देख के बहुत सारे लोगों ने, मेरा देख के मतलब क्या? It was me, just I mean, I got the thing and I took a chance कि चलो लेके देखते हैं. गए पैसे तो गए, but let us try for it, and it works so nicely and it is too good. You can see I'm writing like board पे भी इतना utilization नहीं होता पूरे board का. In first sem I take fourth year का advanced control. So in that, to all it will be there for you also. It's all design, right? Out of it, 7 topics are of design. And then graphs are there, Bode plot means semi-log paper is there. Then I used all those things on this, right? Whiteboard, आपके normal board पे, blackboard or green board पे, you cannot use those things. तो बहुत सारा research कर लिया है ना. So while doing that, why I am telling you all these things? Oh God, मैं कहाँ चली गई? So why I told you all these things, because we are thinking of हाँ चलो theory तो बहुत अच्छा, we got too many tools for that, but what should be done for practicals, right? Practical to is tough to take online. Then some of the faculties come with the solution that yes, why not to go for record the, because we were going to the college, no? So record the practical going on and go it for, I mean, show the video and data related with that. We'll keep on telling. We did that, but still I was not satisfied. Then once I searched that are virtual lab. It is the initiative by Education Ministry, 7-8 IITs plus some good colleges like COEP and all, right? They together form virtual lab. Is online tool available, and using this tool, and I visited that and I found, oh my God, too many things we can do for online practicals also. So it was a very good thing. Then because my area is electrical and electronics, we found out many softwares are also available. So using those softwares, and we started taking the practical. So 20 ka batch, 19 ka batch, 18 ka batch, you'll find, yes, we took the practical online. I'm talking about my area. For mechanical and marine, again, very less things are there. So meanwhile, I was thinking ki on virtual lab, electrical, computers and all those things are very nicely given. What about marine subjects, right? So why not to develop these labs? Is it possible for us? So we tried for that, and now we are nodal center for virtual labs also. So nodal center. Okay. So, and I'm nodal coordinator for that. So I am supposed to now develop also. And it's not me, it's you only. I'm going to take help of some of you only, the one who are good in programming and want to do something else also with this regular syllabus. So we are going to develop, but before we'll develop, we should use this lab. We have to show the number. These many practicals, these many labs we did, and we are doing the thing. So the thing comes, then it should start from first year. Hai na? So obviously then I should be in the first year, and that's why I'm over here for this particular subject. Have you got the scenario? Yes. Yeah, good. Indrajit, good.
Yes, ma'am.
Yeah, good.
Yes, ma'am.
Yeah, okay, fine. Chalo, so I'll clear the board, right? And I'm not going to start with the subject. I'll switch off the video now. Why? Because bandwidth gets affected because of that, and now not required actually. Yeah, just a moment. I'm not going to start with the subject. Keep in your mind today, definitely not. Just try to see the basics. Okay, basics of what you know. Actually, I want to know what you know. Then I'll keep on adding to this. So, you know Mendle sir, Kailash Mendle sir?
Yes, ma'am.
He is your year coordinator, right?
Yes, ma'am.
Yes, ma'am.
So I'm sharing the subject with Kailash sir. So Kailash sir will take AC part and instruments. I'll take DC and magnetic circuits, magnetism and all those things. Take my words. Compared with the previous syllabus, actually this particular 21 ka syllabus is on lower side. It is not that, that good syllabus. That is my feeling. So it's not only your syllabus we are going to cover. Keep in your mind, syllabus to karenge, bahut shallow hai. But I'm going to do the additional things also, which you will require for your second year. Like machines hai, ya third year ka MET hai. Some of the concepts you should know which are not in the syllabus. So definitely I'm going to cover those things also. And what I'm going to do is I'm going to put some assignments based on that. I'm going to give you marks for that also. Everything I have planned. Okay. Only the thing is on Moodle now, this subject, this means first year ka koi bhi subject, it is not on Moodle. So I will start putting, jaise hi wo Moodle pe aayega, I will start putting everything on the Moodle. All the notes and all those things and books and whatnot things. Plus, whatever I'm writing over here on the board, right? I'm going to save it. I'll make one PDF, hardly 1 or 2 boards we used to require. I've seen that thing, right? I'll make PDF and I'll keep on putting all those things on Moodle. So, ek cheez pakka samajh lo, aapka notebook is your best, your notes means, your notes is the best thing to appear for the exam. कोई किसी के notes की, कोई textbook will be for solving the numericals, right? But your notebook will be the best guide, and when it will be when you are writing with me. So I want everyone to write. I'm not able to see what you're doing, but in between I'll tell some of the students to share the screen and show your screen, means switch on the video and share your notebook, right? Show your notebook, what you have written till now. So I should be able to see that thing over there. And now you are in college, right? Right? Yes?
Ma'am. Yes, ma'am.
College
3 divisions are there.
Correct. 3 divisions are there. Indrajit is writing, ma'am, we heard a lot from senior that it is very tough and a lot of cadets are going to have a back. No, it is not true. And it's not that. If you'll compare Indrajit for other subjects like marine, some boiler or some marine machinery, something, right? They had many failures. Compared with that, BEEE ka kuch failure nahi hai. So it's not very tough. It is absolutely, and your syllabus, though, this new syllabus, though, definitely not tough. Very easy to go for. And in the first lecture only, don't think of it. Don't start with negativity. कि ये tough है. आप बोलो ये easy है. हम मैडम और सर के साथ करेंगे. So definitely it is going to be very easy for you. If you go with me, no, I'll give you guarantee 80 plus you will be able to get. But you have to work for that. You have to do everything related to the subject. What I'm going to tell, you are going to do in your notebook. That is going to help you 101%. So definitely not. It's not true. It's not true that the subject is very tough. No. If your concepts are not clear and if you're not telling to the faculty, then it will be a tough thing. You have to keep on discussing with me. मेरी problem है, अगर आप discuss नहीं करोगे ना, I start skipping because the feeling should not be there for me. I'm talking with me, right? You should keep on contributing. कुछ नहीं, गलत है तो गलत है. मैं कोई marks नहीं देने वाली यहाँ पे. While the lecture is going on. So keep on telling, so I'll come to know where you are. है ना? That is the main thing. Chalo, so all the best, everyone. Yeah, good. Chalo. And we'll start with some basic things. I'm not starting with the syllabus now. Yeah. So you heard about resistance. What do you mean by a resistance?
The force which opposes the current.
Okay, the force, don't say it's the force. It is the component of the circuit, right, which is opposing the current. Very good. So what do you mean by current then?
Flow of charges.
Flow of charge. Daksh hai na?
Darshan.
No, ma'am, Darshan.
Daksh. Okay, fine, no problem.
No, ma'am, it was Darshan.
Darshan.
Okay,
Ratnesh Yadav.
Yes, ma'am.
Okay, good. Chalo. So it's opposition to the current. When current, someone said it is flow of charge, rate of change of charge. Very correct. Why this? What do you mean by this charge? I don't understand charge. So can you explain me what do you mean by that? Charge is flowing means actually what is flowing?
Electrons.
Very correct, Jitesh. Electrons are flowing, right? Electrons are having which type of charge?
Negative.
Negative charge.
Negative.
So in a circuit, why these electrons flows? Why electrons are flowing?
Remember difference in potential.
Very correct, Devish. There is difference in the potential, right? So if we are talking about analogy, let us say, because I'm a control person, always I used to talk about the control examples, right? That will definitely going to help you. Okay, chalo, so I'll draw one thing. Yeah, let us say you are having a ball with the line and 2 tanks are there, right? And let us say the level of this tank is this and second tank is this. Okay. Now this valve is opened up till 30%, let us say 30% open है. So definitely it is offering some resistance. So this is analogous to the resistance, right? Now water is going to flow from this pipe till this tank. Do you agree with me?
Yes, ma'am.
Yes, ma'am.
Yeah. So when this flow will stop?
When both the tanks have
Equal
equal
levels.
water.
Very correct. When both the levels will become same, right? At that point, the flow will stop. So previously, when the level was not same, we can say this thing equivalent to the voltage. Now he said no potential difference, voltage difference. You are having voltage difference now. So a level difference means analogous to voltage difference. The obstruction that is there in the pipe is acting like a resistance. And because potential difference is there or level difference is there, you will find yes, water flow rate is there. So आप electrical में हम बोलते हैं rate of change of charge. On the same line here we'll say rate of change of flow. Simple, है ना? So that is the equivalent thing. So here water is flowing. Over there what is going to flow is electrons. Now what I'll do is next lecture may I'll show you one YouTube video very nicely. The this phenomenon is explained in that, right? How the charges flows and all those things. So that's it. That is the thing, and that's why you are going to have the electron flow whenever there will be a closed circuit, right? Okay, so that is all about the resistance and current that is going to flow. Very correct. Then I want to measure this. I came to your hostel and I kept one resistance on your table. Okay, and I'm saying measure this resistance. Tell me the value of this resistance. Can you suggest any of the method? ये resistance का value कैसे पता चलेगा हमको? How will come to know what is the value of this resistance?
And potential and current is known of the.
Devish loudly. Devish
The
loudly.
potential and current which is through the resistor is known or it is unknown.
You can have. See, I
We
gave
can
you.
apply
Listen.
Ohm's law.
You can try Ohm's law. Okay, what you are going to do then?
And if we do V upon I, will get R, ma'am. It's V equals to IR.
Okay, so you should have a circuit for that, right?
Yes, ma'am.
Can you make that circuit? Can you do annotations on the screen? You're joining with phone or your phone or laptop?
Laptop only.
Acha. Any of you join with phone and can draw the circuit? Okay. Otherwise, what I'll do is, who said Devish, right?
Yes, ma'am.
Yeah, Devish, I'll stop sharing. You share your screen and can you draw the circuit?
Yes, ma'am. I can.
Yeah. Okay, I stop sharing. Try to draw it. Share your.
This screen sharing is disabled, ma'am.
Wait. Just a moment. Advanced settings and all participants. Yeah. Now you will be able to share. Yeah. Very correct. Very good. Okay. बस नेगेटिव लिखने की जरूरत नहीं है.
Yes.
You had drawn the circuit, but how you will get value of R?
Ma'am, if we have potential V over here
हाँ
and the current is flowing.
हाँ तो you have to measure the current also, right?
Yes, ma'am. So we need an ammeter somewhere over
हाँ
here.
so I want you to draw it. Draw it. बस ठीक है, सीरीज में ड्रॉ किया. And how will come to know what is the voltage?
Voltmeter in parallel.
करो, यही तो चाहिए मुझे. Very good, absolutely correct. V by I.
V and I and V by I gives R of this resistance.
Absolutely, very good. Stop sharing. Very correct. So they was talked about. Just a moment. हाँ अच्छा, मेरा लिखा हुआ चला गया. 1-2 मिनट. Laptops given to you by college?
No, ma'am. Personal laptops.
Laptops दे रहे हैं
Personal laptops.
Lenovo laptop. No.
हमें मिलेंगे लैपटॉप?
पता नहीं
They
मैंने.
give us laptop. CR please provide. ऐसा हो ही नहीं सकता.
मैंने बस मैंने ऐसे सुना था कि फर्स्ट ईयर को देने वाले, शायद फिर वो नेक्स्ट.
Yes, ma'am. That was for the exam. If someone's laptop was malfunctioning, they could use it.
No. Not for exams. जैसे आपको manuals देते हैं, books देते हैं on the same line. I heard that because principals are only once discussed that yes, we are going to give to first year the laptops also, but might be it will be in the next year. मतलब the coming first year का batch उनके लिए होगा शायद. I don't know. No, not as a gift. Nothing is as a gift. Keep in your mind. Whatever knowledge मिल रहा है ना, वही gift है. बाकी कुछ gift नहीं है. Okay, so we were talking about resistance. So point number 1, he said Ohm's law we can apply. Very good, very correct. But as of that, I'm just saying कि नहीं है मेरे पास ammeter voltmeter नहीं है. Then any other way to get the resistance?
Like if you know resistivity, then rho L by.
Very good, absolutely. So he's saying you should know the resistivity, you should know length of the wire, you should know area of the cross section. Very correct. You will be able to get the resistance. Very nice. Any other way? नहीं है मेरे पास ये parameters. Then सब पता है आपको. I'm not. I square RT will be just Ohm's law का extension. तो ठीक है. Then you can say I am aware of the power, है ना? Then I'll go for I square R, or by V square by R, right? And I'll be able to get or energy. तो ये सिर्फ उसी का extension है. तो ठीक है. I have added it. Fine. Any other way to get a resistance of a resistor? And all these things you already learned. I'm not asking you anything which you are not aware of. पक्का आपको सब पता है. You have to think, and this is very important. बोलो. और कुछ नहीं याद आ रहा? One of them, हाँ, yes, Daksh.
Ma'am, can Wheatstone bridge be there?
Very good, absolutely. Wheatstone's bridge. एक मिनट, हाँ, कुछ गलती किया.
Ma'am, P would be equal to VI.
एक मिनट, let me write it. नहीं, एक मिनट, ये जा नहीं रहा है. हाँ, ठीक है. So he said Wheatstone's bridge. Then someone was trying to say some more thing. What it was?
Ma'am, P would be equal to VI.
फिर से बोल. हर्ष.
Power would be equal to V into I.
I've written no.
Okay, ma'am.
Third point I have written. You are able to see my board, right?
Yes,
And
ma'am.
he was sleeping, ma'am.
What? Come again? Who said? Okay. So Wheatstone Bridge. Wheatstone Bridge is the most accurate method for measurement of resistance. Yaad rakhna. Because whenever the control components will be there, when you will be there in the plant, your ship is also one of the plant, right? And individual processes are there. So wherever the need will be there, you want to measure resistance, you will find we are not using all these things. We will directly go for Wheatstone Bridge. Why? Because it is the most accurate method for measurement of resistance. Good. One more thing is there. Now, these first two things which I have written, okay, some condition is for that. What is that condition? Ohm's law apply करने के लिए and R is equal to rho L by A to apply. One condition is there. What is that condition?
Voltage remain constant.
अरे सेकंड पे वोल्टेज कहाँ से आ गए? दोनों को एक कॉमन कंडीशन है. What is that? What should be constant?
Physical condition.
हाँ.
Ma'am, DC current.
Temperature. Very good. Temperature should be constant. I'll write it over here. Temperature should be constant to apply these formulas. है ना? So if the temperature is changing, what is the formula to get the resistance?
The temperature coefficient.
हाँ बोल. Formula बोल.
Alpha R not equal to RT 1 plus alpha delta T.
उल्टा. RT is equal to R naught 1 plus alpha delta T. Very correct. Absolutely. Actually, alpha naught बोलना चाहिए. Same temperature, zero temperature. You may have change in the temperature over there also. Not necessarily your alpha should be at 0 degree. Whatever is the temperature, at that point ka alpha and at that temperature ka resistance you should be aware of and done. I have not told you anything. Your friends only told you all these things. मैंने एक भी चीज का आंसर नहीं दिया, है ना? इसका मतलब है you know the thing, but कहीं पे तो वो ब्रेन में कहीं पे तो फंस गया है, जंग लग गया है, तो ब्रेन का जंग निकालना है ना? And electrical ऐसा सब्जेक्ट है, it is like your mathematics. Maths में logical thinking करो, you will get, I mean, everything will get solved. The same thing. Some of the things you have to remember the basic things and keep on applying. Keep on applying your logic and definitely you'll be able to get all the concepts. इतना simple. That's it. तो ये हुआ resistance. Okay, I'll clear the board. Then the next thing comes series and parallel. ये सारा आपका subject है. मैं सिर्फ I want to know how many things you already learned. So I will invest less time on those things, and the thing which you don't know, we'll go for more time for that. We'll invest more time on that. So when the resistances are in series and in parallel, चलो series की बात करते हैं. तो when you are going to say the resistances are in series?
And the resistors are in a line.
In a
Line together.
in a line. You mean to say these two not are in series?
Yes, they are in series, but they are in the same circuit. I mean the wire.
When they are same, the current passing through them.
And current is same in both resistors.
Very correct. Absolutely. Whenever the current which is flowing through the resistances is same, right? That means the resistances are in series. So I'm drawing one thing and I want answer from your side. Only those things you will answer which I am going to ask you. Can I say R1 and R2, they are in line as per what Harsh said? So whether R1 and R2 are in series?
No, ma'am.
No. Sahil is saying no. Any of you want to say yes, they are in series? Harsh?
Would be distributed in R2 and R3. So I1 would be equal to I2 plus I3 maybe.
Correct. So you are talking about current. So my question again remains the same, whether R1 and R2 are in series.
No, ma'am, then they are not.
No, they are not in series. Whether they are in parallel.
Yes, ma'am.
Prathamesh is saying yes. I have not said is correct or wrong. Prathamesh said R1 and R2 are in series.
Oh, ma'am, in parallel.
Oh, sorry. He said they are in parallel. So whether Pratham...
I think R1 R2 is in series because R3 is Arthit na.
Acha, wait. So Darshan is saying R1, acha, I'll write it. R1 and R2 in series. Huh? ठीक है? Harsh नहीं, कौन? Darshan?
Yes, ma'am.
Okay. Anyone object this thing? So I'm saying this is wrong.
Yes, ma'am, because R1 and R2 are in parallel.
Achha.
Parallel.
So he...
Yes, ma'am. Yes, ma'am. The current is getting distributed. That is correct, ma'am.
Okay. So many of the students, Himanshu is also saying they are in parallel. I'm saying this is also wrong. Who feels that both the things are wrong? That means you don't know when to call them. हाँ ध्रुव बोल. ठीक से बोल, मुझे ऐसे आधा अधूरा समझ में नहीं आएगा. Talk properly.
हम जो करंट R1 से R में
हाँ
वो सीधा अर्थिंग हो जाएगी ना.
अच्छा, एको आ रहा है. ठीक है. सीधा अर्थिंग क्या होता है? What do you mean सीधा अर्थिंग? अच्छा. So they are not in series, they are not in parallel. Now why I'll tell you. Series में होता ये disconnected होना चाहिए. Otherwise,
yes,
हाँ, otherwise this ground is not there. Fine, no current will go over here. Everything through R1 will go to R2. You can say these two are in series. In that case, this R3 will not be in picture only. But if it is grounded, definitely these two are not in series. These two are not in parallel also. Why I'll tell you. Parallel, when you say the resistances are in parallel. कब बोलते हो? Resistance.
When the voltages are same.
The potential is same.
Very correct. So whether potential across R1 and R2 is same.
No, ma'am.
No, ma'am.
So definitely they are not in parallel. आपको चॉकलेट पता है ना? कौन सा? पुराने वाले चॉकलेट्स I am talking about. What you used to have one, right? पूरा wrapper. You fix it over here, twist करते हो यहाँ पे भी side twist करते हो. तो चॉकलेट ध्यान में रखना है for parallel. R1 and R2, you should have both the ends connected. Both the ends, if they are connected, then only they are in parallel. Otherwise, they are not in parallel. Finished. Simple. So you can see R1 ka one end is going to 5 volt. Another end is going to 0 volt. So they are not in parallel. So I want to ask you, out of these three, which are those two resistances which are in parallel? कोई parallel combination है क्या इस diagram में?
R2, R3.
Very good. R2 and R3 are in parallel. Why? Because they are connected over here, shorted. Second point देखो, ये 0 पे है, इसका second point भी 0 पे है. So as if they are shorted, right? So as if you are having R2 and R3, 0 on one side and whatever. Let us say I'm mentioning potential as V1. So V1 on one side, R2 and R3 are in parallel. Yes or no?
Yes, ma'am.
Yes, good. Dhruv. Yeah. किसी को doubt है तो again I'll repeat. नहीं है. Okay.
मैम एक और एग्जांपल से बता दो. मैम रिपीट
Okay, I'll repeat. Whenever you are saying two resistances are connected in series, they should have same current flowing through them. So you should not have any branch. If branching is there and something is connected on this side, matlab some potential is there at this end, they are not going to be in series. Right? Whenever you will find a branch, there will be division of the current. You will find, yes, they are not in series. One thing. Second thing is, if I'll have two resistances connected like this, X and Y, hai na? One end is connected, another end is open, might be some other circuitry on this side, they are not in parallel also. What is the condition for having parallel components? Second end also should be shorted. So you can see in this diagram, R2 and R3 connected over here. I'll change the color. Connected over here, having potential V1 at both the ends. R2 का and R3 के दोनों end पे V1 है. Second end देखो, zero है, grounded है. इसका second end देखो, battery के zero को connected है. That's why purposely I have written zero over here. Otherwise, we used to say 5 volt का battery. You may have 1 and 6 का combination also, that is also 5 volt. You may have 9 and 14, that is also 5 volt. But that's why purposely I have written over here, that is also at 0 volt. And then definitely, दोनों की condition, मतलब मैं अगर यहाँ पे लिखूं R2 and R3, ये potential है V1 and the other point का potential है 0 volt. So both the ends are at same potential for R2 and R3, and that's why they are in parallel. Understood, everyone? Yes? Any query, any doubt? Even if you have understood, say yes, ma'am.
Yes, ma'am. We understood.
Yes, ma'am.
Good, good. Chalo. I thought of discussing many things, but I completed only 2 points. And next lecture onwards, so we have to go for regular syllabus, है ना? तो ठीक है, basics हमने थोड़ा सा कर लिया. One more thing we'll discuss and then I'll stop. You are aware of the 3 basic components of electrical circuit, right? Yeah. What is difference in the What is difference in these 3? Basic difference in terms of current and voltage. If I'm talking about AC provided to all these 3, what is the basic difference in these 3? Okay.
Energy is different for 3.
Energy is different. Very correct. आप और आगे चले गए. मैं इतना आगे वाला एक्सपेक्ट नहीं कर रही थी, but good. You talked about energy, but I will not talk about energy now. I'm just talking about voltage VR and current I, which is passing through, which is okay. Best है कि I'll draw one AC circuit. You did your AC circuits in your 12th, right?
Yes, ma'am.
Yeah. तो आप कुछ AC voltage दे रहे हो, because of that current is flowing. This is your R, this is C, and this is L. What about the angle between V and I for resistance?
90 degree.
Resistance.
So current lags the voltage.
अरे प्रथमेश, resistance. कोई नहीं बताएगा क्या? किसी को नहीं पता? No one is aware of? Okay. Okay, fine. That means you don't know this thing. ठीक है. किसी को भी नहीं पता मतलब you don't know this. Anyone want to say anything? No.
You are asking phasor angle.
Yeah, I'm asking phasor diagram. The angle between voltage and current. what it is for R, what it is for C.
45 degree.
R के लिए तो 0.
Okay.
He is copying from Google.
Devish, you are right. Acha, you are searching it on Google. Very good. Google use it. Are koi problem nahi. Even if you are searching on Google, no, it's a very good thing because you are using the facility which is given to you in good manner. तो problem क्या है? आप अच्छी चीज search कर रहे हो ना? So very nice. Proudly say I searched on Google and I found out that for resistance, V and I will be in phase. No angle difference. Theta is going to be equal to 0. Very correct. Then what it is for capacitor?
90 degrees.
And what it is for inductor?
Again 0.
Again 0. Okay. So all those things are wrong. Someone said 90 degrees. That is correct.
That's 90 होगा.
मैम गूगल देख के भी.
तू यही काम कर सकता है बाबा. कौन क्या कर रहा है? तू कुछ कर. है ना? वो क्या कर रहा है? वो गूगल पे जा रहा है and he is trying to find out why you are worried for that. Right? You do something, you search
एक
and
में करंट लीड करता है 90 से एक में लैग करता है.
very good. One of the component it leads, one of the component it lags.
पर फेजर एंगल तो 90 रहता है.
हाँ, but phasor angle but एक lag करेगा और एक lead करेगा तो difference है ना. One goes in the positive direction of y, one goes in negative direction of y. So I mean big मतलब they are actually acting in the opposite directions. तो ठीक है, बस इतना डिस्कशन आज के लेक्चर के लिए काफी है. नेक्स्ट लेक्चर में हम एक्चुअल सिलेबस को स्टार्ट करेंगे. ओके. मीनवाइल आपके कुछ भी डाउट्स हो इलेक्ट्रिकल से रिलेटेड तो आप फाइंड आउट करो. तो ये है डिवीजन 2. 1 मिनट है. हाँ, आई कैन गो फॉर अटेंडेंस ऑल्सो. सो 16 अभी ना मूडल बना नहीं है तो मूडल पे आपका कोर्स नहीं है तो आई एम नॉट एबल टू गो टू मूडल एंड पुट द मैं आई एम गोइंग टू डू द सेम. मैं 4 जगह पे अटेंडेंस नहीं डालूंगी, डायरेक्टली मूडल पे डालेंगे. तो अभी टाइम बिंग व्हाट आई एम डूइंग इज div 2 का मैं अटेंडेंस लेती हूँ और फिर बाद में मूडल पे डालते हैं. तो CR Animesh, am I right?
Ma'am, he is having some mic issues.
Okay.
So
he is here. Animesh, unmute yourself.
he has messaged me that he is having some mic issues.
ठीक है. तो आपका DCR है क्या?
I'm Prathamesh.
Prathamesh,
I am DCR.
Prathamesh is sleeping.
Prathamesh, don't tell me all these things. मुझे कुछ लेना देना नहीं है. जितने लोग जागे हैं ना.
I am DCR of div 2.
Who? Sahil?
Sahil Jagtap, yes ma'am.
Sahil, yeah. Sahil, your number starts from? Class के number starts from?
042.
042. Okay. So 42 is there. 43, 44, 45, 47 absent है. 484.
Ma'am, actually the IMU IDs are not in series. They are scattered away.
And some
randomly.
Other students are also included in this because of IMU numbers.
Okay, fine. So how I should go for attendance? I'm not able. I mean, now I'm clueless कि मैं attendance कैसे लूँ ये क्लास?
मैम बस एक ही बंदा एब्सेंट है मैम क्योंकि 34 क्लास की स्ट्रेंथ है और टोटल
नहीं मैं प्रथमेश एक मिनट. Sahil will talk with me now. Sahil?
Yes, ma'am, I am looking.
हाँ, आप अपना काम करो. I'll wait for 1 or 2 minutes.
Ma'am, Devansh Tandon is absent. Actually, he is gone for vaccination.
What is his number?
I will look.
हाँ, you find out.
Yes, ma'am. He is at the hall.
Ma'am, 055.
055. Gone for?
Ma'am, he is not absent. He has gone for vaccination.
हाँ, ठीक है. तो I see, Sahil. He is absent means he is not in the list now. पार्टिसिपेंट के लिस्ट में नहीं है तो वो एब्सेंट है मेरे लिए. So you just tell me those numbers who are not in the list but they are in your division. That's it.
Okay, ma'am. Okay.
Yeah.
Ma'am, all others are present.
All others are present. So I have written 055 absent. Okay, absent matlab I'll put a remark over there. Gone for vaccination. Chalo, good. Chalo, all the best everyone.
Ma'am.
Thank you, ma'am.
Bol.
Excuse me, ma'am.
Bol.
I'm 055 present, ma'am. Ma'am, there was a connection problem, ma'am. I was gone for vaccine, ma'am.
ठीक है, कोई प्रॉब्लम नहीं, मैंने निकाल दिया आपका नाम मेरे लिस्ट से.
Okay, ma'am. Thank you, ma'am.
Okay, साहिल unmute yourself.
Yes, ma'am.
Strength क्या है आपके क्लास का?
34 students.
34 and including me it is 35. So done. चलो, ठीक है. चलो, all the best everyone. I'll stop sharing.
Thank you.
Thank you, ma'am.
All the best.
जय हिंद मैम.
जय हिंद.
Jai Hind, ma'am.
Vande Mataram.
वंदे मातरम.